This video is on kinematics. The problem is Dylan is approaching a stoplight at 30 meters per second. The light turns yellow when Dylan applies the brakes and skids to a stop. If Dylan's acceleration is 8 meters per second, then determine the displacement of the car during the skidded process. So I first started by drawing a picture of what's happening. There's the car. When I see the yellow light, it starts to slow down, and there it is. That's the final velocity, then the initial velocity. Our knowns is our initial velocity is 30 meters per second, our final velocity is 0 meters per second, and our acceleration is negative 8 meters per second squared. Unknown is displacement. We had to find the displacement. So what I did was I started with the VF squared equals the velocity initial squared plus 2 times acceleration times the displacement. So I filled in for the velocity of final squared. You got 0 meters per second squared, and then it equals 30 meters per second squared plus 2 times negative 18 meters per second squared times the displacement. And then I substituted, did the squares, and that still gives you 0 meters per second squared equals 900 meters squared divided by second squared plus negative 16 meters per second squared times the displacement. So then I broke it down and got to 16 meters per second squared times the displacement equals 900 meters squared divided by second squared minus 0 meters squared divided by second squared, and I got to find the displacement. And what you do is it's 900 meters squared divided by second squared, all divided by 16 meters divided by second squared, and that gives you the total displacement of the car, of Dylan's car, as he hits the brakes during the skidded period is 56.3 meters. And that is solving kinematics, and you use the VF squared formula equals the velocity initial squared plus 2 times acceleration times displacement. And that is how you use kinematics in physics.